I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have
enough. Okay, what I've done is to try to stabilize this, what I believe is asbestos tape. I sprayed it with clear coat, and I will put a layer of aluminum tape, aluminized tape around that, just to be double sure it's okay. I mean, it's probably not, well, I don't know what it is. Anyway, that's what I did. And now I'm going to see if it works. I have not taken it apart and cleaned the bearings yet. I did ohm out the coils, and recall there's a primary coil to turn the motor, then there's a secondary coil here, here and here. The leads go here and here. That's used to power the solenoid that's in the base of the turntable. Solenoid pushes on the clutch and engages the whole thing. So I'm going to do something here that you should not try at home, kids, because it could be dangerous. And the dangerous part is I've got open AC here. I've got a short plug out of my junk drawer. I've trimmed the ends back. I've hooked a couple of cables to each end. And now I'm going to hook those to the primary coil here, which is B and D. And we'll see if this thing goes around in a circle, which would be cool if it did. Remember, don't touch. I'm just going to plug this end in, and we'll see. This is a very low torque motor, so I don't expect it to go rocketing off the table when it starts, if it starts. Ah, there it goes. Excellent. The bearing's a little growly, but it'd certainly be loud on a turntable, but we'll clean those up and make them work better. The other thing I was curious about was how many volts AC that secondary winding was putting out. So I've got my meter here, and I'll connect up to these two leads for the secondary and see what it's producing. Oh, interesting. 7.1 volts AC. I presume that's RMS. Don't know for sure. Anyway, 7.1 volts AC out of wall socket. So that's working as well. That should certainly be enough to fire the solenoid and the turntable itself. So very good. I'll stop here, and by the way, a short lesson on simple AC motors like this. This is a shaded pole AC motor. And the reason it's shaded is this coil, the primary coil, turns this iron outside into an electromagnet. And where's a pointer? Here's a pointer. And without that little, there's a winding of pretty heavy duty copper wire just wound around there once and over here, and they're slightly off center. The way this would work would be, this would be the North Pole, South Pole, and then they'd switch, because it's AC, it's going up and down, they would switch to the north here, south here. This copper winding around each pole is about 90 degrees off, out of phase from the wall AC coming into this electromagnet, this now electromagnet. And without those, this motor would just go back and forth, would just shake back and forth at 60 cycles. It would try to go that way, and then the phase would change, and it would try to go back the other way, and then the phase would change and go back, and just rattle back and forth. But these shading fields here and here say north. When you first turn it on, let's say that north is on this side, and well, do I want to say that? I'm not sure which way I had it turned. I can't recall. What happens anyway is this energizes, which energizes that about 90 degrees later in a 360 degree cycle. About 90 degrees from the initial energy, this energizes this, which gives it an extra tug in one direction. And then when the rotor starts to go, the same thing happens. The current changes polarity, and this one gives a little extra boost that way. And so the whole thing encourages it to go around and around and around. Once it starts going around, it pretty much maintains it. But that's the way that it starts the rotation of the rotor. And without that, it would just sit there and vibrate and be useless. Very simple, very low torque. They don't have any starting power at all to speak of, but sufficient for a turntable, certainly. Okay, the first thing we have to do to dismantle it is take this spring off the shaft of the motor. The spring is interesting. It's a specific diameter, so that this machine was built to run in the United States at 60 hertz, and this shaft allows this motor to produce about 70 RPMs.
But that ain't the way I heard it.
Enough speed, I should say, to turn the platter at 70 RPMs. This is a 70 RPM record player. For countries where they sold this at 50 hertz countries, where AC was at 50 hertz, they had a different spring, and this spring just slides on that shaft. Because it's a spring, it tends to tighten itself down. And if you were a technician and were switching this over to 50 hertz, you'd take this spring off and put a different spring on there, resulting in a still turning the platter at 70 RPMs, given a different motor speed at a different operating frequency. So I'm going to take this off to get this top bearing, or this bearing out, and we'll unscrew these screws and take that bearing out. We'll start with those and see how this goes. Or they go all the way through. Could be they go, well, no. Yeah, they do. All right. That's okay. Come on here. Boy, it's a gummy screw. Everything in this turntable is gummy. There it comes. Ooh, long screw. So it's the post and a washer on this side holding down the spring. Post washer. And on this side a very long screw and a washer holding down this bearing here. So we'll leave that in place for the moment. Turn it over and take off the other side. Post, the washer, then the spring holding down the bearing, There's a felt washer right there that's supposed to hold oil when you oil it, and it hasn't been oiled in some decades, I'm willing to bet. And there's the bronze bearing itself, and there's another, looks like felt, or not felt, some kind of nylon or something washer in there too. Have to make sure not to lose that. Then the rotor should just lift out, and it does. And on this side, we've got the other bearing. Oops, bushings. Bushing on each side of that. Then long screws, bushings on both sides. These are actually standoffs, I guess. More accurately, these are bushings. That's a bushing. That's a standoff. So then standoffs on the other side. Another spring. And then another bushing with the screws on the outside of that. So that's how it goes together. All right, I'll clean all these up. I will swab the bushings, the bronze bushings. Oh, they're on a swivel too. Anyway, I'll swab those out with some kind of degreaser and then oil them up. Probably with 3-in-1 because that's what they used in the olden days. And make sure that this felt pad gets nice and oily too. Pretty symmetrical though. This looks pretty good. What you look for is scuffing to see if it's been rattling around inside of here, and it has not been. So that's a good sign. That's a good sign. What I will do is give this, there's a lot of material built up on here. And I'll clean this, and I might give it just the lightest sanding too. We'll see. Anyway, I'll do all that and then come back. And one thing I noticed when cleaning these, well, two things I noticed. One is this holds this in place. This holds the bushing in place. And I was looking very closely at it, and these holes don't have any edge. But this one has a raised bit. Maybe you can see it in there, but it's a raised bit around the outside, and it's dished in on this side, which says to me that's how it has to fit on the bushing. I suppose it wouldn't hurt much if you put it back the wrong way, and I think is the wrong way. But it looks like it was designed specifically to be put back that way. So something to keep in mind during reassembly. The second thing I've noticed is I've got some kind of generic household cleaner here. And this has that varnishy-like stuff on it, that yellow stuff. And this household cleaner will barely touch it. But if I use some plain old isopropyl alcohol on the other side, it cuts right through it. So my soaking the bottom of the turntable, all the gears and things in the bottom of the turntable in soapy solution probably isn't going to do a bit of good. I may have to get a gallon of isopropyl alcohol and swab it all out anyway. See, the isopropyl alcohol cleaned the yellow varnish right off there, which is good to know. Let's take a look at the bushings themselves. As I said, it's the bushing just rests in this pocket, and it's surrounded by felt. In this case, 2 felt washers. And their job is to kind of provide oil, an oil bath for this thing. And that's the looks like bronze to me with a steel insert in the end. And that's where the shaft of the rotor resides. Just sits in there and turns. Oh, that popped right out. And that can be pushed out. I didn't know that. Okay. So don't overdo it. Maybe that's why it sits down in there. So you can't blow the end out. Oh, I hope that's easy to get back in. Yes, it is. Thank goodness. Okay. So anyway, as I just put this in here, I can feel it's just gummy like the rest of the radio. I've cleaned these up. The rotor's up. The shafts are clean now. I think I'll repop that steel insert out and swab this out with a Q-tip and alcohol, and then put it back in, clean the receptacle out, put it back in there, and then oil the inside of the bushing and these felt pieces as well. Although I don't know what good the felt pieces, I think the felt pieces are less to oil this than to catch dripping oil when it's oiled. So I think I'll leave the felt pieces dry. Just put the oil inside. I can't see any reason why applying oil to the outside of the bushing would do any good at all. So I won't do that. Another clue regarding the nature of these, I said that there appeared to be, there appears to, I'm sure there's a name for this, I just don't know what it is, but this appears to be pressed in slightly that way, creating a lip right there. And as I was cleaning the bushing, I realized that it has a collar right around there. And guess what? The collar fits quite snugly inside that space. So now we have a clue to how to reassemble it. So the little steel plug, which is here, goes into the non-collar end. I just lied. That just fell in there. It didn't fall in there before. Oh, it fell in there too. It must have fallen in because I got it clean. All right, so I'm going with my original assumption. The steel plug goes in like that. Then the shaft, or then it's retained in place by this. And of course it goes inside this, and then the shaft of the motor fits in there like that. So I think that's kind of that's got to be it. That's what makes sense. So I'll put it back together. I'll clean the other bits and put it all back together, and I'll see if I was right. Okay, just to document, the steel plug is in the end. That goes down inside this holder. Then the felt washers go on. And the other one. And the spring that retains the bushing fits around the collar of the bushing like that. And that's the completed assembly. And that's what we'll put back together. And interesting little difference with this side. First of all, the holder has a hole through it, as does the bushing. So there's no plug in the bushing on this one. It just sits in there, then with the felt washers and finally the spring retainer. It goes like that. It might have something to do with thrust. This might be, the other one might be sealed on the end to keep the shaft from moving out that way. And this one is not, because it doesn't matter. And also you can put a drop of oil inside this bushing really simply. Interesting. Same deal. The bushing itself has a collar on it. 2 fillet washers, a collar. Anyway, I'll clean this up and put it. It's funny what you learn when you look and think a bit. Very clearly, this bushing with an end cap with a sealed off holder goes on the short end of the rotor shaft, because it's got to stop there. This bushing has to allow the long shaft to get out so it can do some work. So of course the bushing itself is hollow. Of course it goes all the way through the bearing plate. It all makes sense when you stop and use your little tiny head and give it some thought. Now reassembly. Here's my problem. As I spin this, it spins nice and freely, except the cooling fins are hitting this housing. So I suspect I've got this flat washer on the wrong side, which doesn't make a lot of sense because these holes in this bearing holder are ginormous. Looks to me like it needs a washer there. The other possibility is these standoffs are different height, although my eyeball says they are not. Interesting. Let's see, is it possible this rode the other way around? That would seem silly. But not impossible. Let's see. Like that. That would certainly hold it up off the fan blades. Huh. Wouldn't that be entertaining? Sort of. It's possible that when current is flowing through here, it centers the rotor automatically. When I tighten these, I have to make sure that they're pretty square. I will have to go back and review the original video of taking this apart, but right this minute, this looks right to me. Because otherwise, there's no way that the fan blades would clear this. They'll clear it on this side because they go up around the bushing housing. And it sits up like that, so gravity, our old friend gravity, is going to work again and keep it in place. I think that's the answer. Gravity will hold it like this and keep it in place. It spins nicely. I'll tighten this down. We'll try it out. Then I'll review the video afterward to make sure I still agree with myself. There's the 60 hertz spring back in place. I'll tighten these up. We'll give it a shot. Very same dangerous setup. Don't do this at home. And don't tell anybody you saw me do it. I'll see how it goes. That runs fine. Lovely. It's a lot quieter. I think I'll add a drop of, yes, good old-fashioned 3-in-1 is what I'm using. Right in there. That made it quieter instantly. And the other side, I can't reach. Yeah, well, I can. It's right here. There. Whisper quiet. Oh, sorry, that was completely off camera. So we had a drop of oil here and a drop of oil here. It's a little tougher on this side because that bearing is covered. This one is exposed, obviously. Now I'll soak up the excess oil. And it's lovely. Working like a charm. So I will unplug it so I don't kill myself. And put the aluminized tape around that. Still spinning. Oh, good. It's working very well. I'm happy about that. Put the aluminized tape around that and show you a picture and be done with another video. Bye.